So in this video, we're going to do an elevator problem. These always involve force and acceleration. You're either solving for your acceleration in the elevator or possibly the weight or the normal force. So let's go ahead and go through this simple example problem. So we have a woman that stands on a scale at home and it reads 540 newtons. So remember, weight is a force, and the force that she's exerting on the scale when it's not moving at home is 540 newtons. And then she takes the scale into an elevator, and the elevator is moving and it reads 600 newtons. So we want to know what her acceleration is based on what the scale is reading when the elevator is moving. So you'll see a lot of these problems where you have a person in an elevator with the scale. That's kind of weird, but it gets the point across. So what do we know here? We know that her normal weight, her mg, is 540 newtons. And then we have what the scale is reading in the elevator when she's moving. This is actually just the normal force that the scale is exerting on this woman. And this is 600 newtons in this problem. So again, this is what the scale reads. So let's go ahead and draw a picture. So we have our elevator, our lady in the elevator, and she's on this scale. So there are two forces acting on her when she's in this moving elevator. So we have her weight, and then we have the normal force. Right, so just two forces, and in an elevator problem, you're just moving in the vertical direction. So everything that we're doing here, everything is along the y direction. So we don't actually need to break anything up into components. We don't need to include any forces that would be in the x direction. There are none here, but we're only worried about the y direction. Okay, so we're just going to use Newton's second law. And that's the sum of the forces, also called the net force, is equal to mass times acceleration. So we just have two forces acting, right? We have the normal force in the positive direction and then the weight in the negative direction. So we have N minus W equals mass times acceleration. So we're just solving for our acceleration, right? So that's A equals N minus W over the mass. But we don't have the mass, right? So we have to find that. We do have the weight, and we know that the weight is mg. So let's just use that to find the mass real quick. That's going to be mass equals weight over g, and we have to use her actual weight, right? So the weight when she's not accelerating. So that's 540 newtons divided by acceleration due to gravity, 9.81 meters per second squared. That gives us a mass of 55.0 kilograms. So now we have that. We have the normal force and we have her weight. So let's go ahead and plug everything in. So that's 600 newtons minus 540 newtons divided by the mass, 55.0 kilograms. That gives us a positive acceleration of 1.09 meters per second squared. So this is our acceleration, and it's positive, so that means she's either accelerating upward or she's going downward and decelerating. And so for elevator problems in general, if the normal force is greater than the weight, the person is either accelerating upward or going down and decelerating. And if the normal force is less than this person's actual weight, then they are either decelerating upward, so decelerating while going up, or accelerating down. And so that's pretty much how all of these basic elevator problems go. We'll go through another problem in another video where we're trying to find the force instead of the acceleration.